So now that we know how to label our sides in trigonometry, the opposite, the adjacent, and the hypotenuse, we can now start to do some calculations, okay? And before we look at that, we're going to come up with an acronym, and it'll make more sense as we go along, so just bear with me. The acronym is SOH CAH TOA, okay? Now, what this means is that for the SOH part of the acronym, that is saying that the sine, don't say sin, it's sine. The sine of my angle theta, that is equal to the opposite side divided by the hypotenuse, okay? So we remember what our opposite sides and our hypotenuse side and our adjacent sides are, and we start to see those popping up in these equations. Okay, the CA part of our acronym is saying that the cosine of theta is equal to the adjacent divided by the hypotenuse. And the TOA part is saying the tangent, TAN, of theta is equal to the opposite side divided by the adjacent side, okay? And you should be able to see these buttons, sine, cosine, and tangent. They should be on your calculator, your scientific calculator, okay? And we're going to start to use those now. So, for example, here we're going to have a right-angled triangle, okay, with our little right angle in the corner there. And we're going to have an angle here of 30 degrees, okay? So that is our theta angle, okay? So this angle in here is my theta. That's the angle of interest. Now, I'm told that my hypotenuse is 12 units long, okay? And I want to try and find what x is down the bottom here. Okay, so let's label what our sides are. So because my theta is up the top, remember this would be my hypotenuse side, this bit here would be my opposite side, and this side here would be the adjacent. Now the only two sides which are of interest to me here are my hypotenuse, my 12, and my opposite, which is my x. Okay, so they're the only two sides of interest. So what I need to do now is I need to come up here to my acronyms, and I need to find which one incorporates the opposite and the hypotenuse. So it's not going to be this one because this incorporates the opposite and the adjacent. It's not going to be this one because this one incorporates the adjacent and the hypotenuse, but it's going to be this one. This one here incorporates my opposite and my hypotenuse. So here we're going to use sine. Now, how do I solve for my side x? How do I work out what that is? Well, I use the formula that's written up here in my SOH part of the acronym. So we see that the sine of theta is equal to the opposite divided by the hypotenuse. That's just the formula that's written at the top there. Now I know what theta is. I can start to substitute some values in. I know that theta is 30 degrees. Okay, and I know that the opposite is my x. That's what I'm looking for. So we can pop an x into there for the opposite. And my hypotenuse is my 12. That's this length here. So now I just need to rearrange this equation and solve for x. So at the moment there's a divide by 12 with my x that I don't really like. So I can get rid of that by multiplying both sides by 12. And when I do that, I see that this divide 12 and this times 12 cancel out, and I get that x is equal to 12 times the sine of 30 degrees. Now, if you pop that into your calculator, you should see that x is equal to 6. So based off of this information, with one side and one angle, we can now work out some different side lengths. Okay, so down here, we can see that this side here is equal to 6 units long. If we take a look at another example, okay, so we'll keep our acronym at the top, but this time we'll look at a slightly different question. We'll have our right angle again, okay, right angle triangle, so that's it there, okay, and we'll let this angle down the bottom here be 40 degrees, and we'll let this side length here be 7, and this is what we're trying to find down the bottom here, our y. Okay, so if we assign our sides, we see straight away that this angle in here is our angle of interest. That's our theta. Okay, now I know that the hypotenuse is the longest side, so that would be our h here. My opposite would have to be over here, and my adjacent is going to be my y. So the sides of interest to me now are the h and the a. And if we have a look up here at our acronym, we see that it's the cosine which incorporates our a and our h. So we get that the cosine of theta is equal to the adjacent divided by the hypotenuse. And now we can start to substitute some values in. So instead of theta, I can put in 40 degrees because we see that that angle there is 40 degrees. So 40 degrees. The adjacent is my y. That's what I'm trying to work out. And my hypotenuse is 7. Okay, now I can rearrange this equation to solve for y. Okay, what's with my y at the moment that I don't like? I have a divide by 7, so we can multiply both sides by 7 to get rid of that. We see that that divide 7 and times 7 cancel out, and we're just left with y over here, so y is equal to 7 lots of the cosine of 40 degrees. Okay, and if you put that into a calculator, this bit here, 7 times the cosine of 40, you should see that y is equal to approximately 5.4. Okay, so based off of this right angled triangle, if I remove all of the working out here, okay, so just this right angled triangle here that we're given in this problem, I can use my trigonometry to work out that this side length here is equal to 5.4 in length. Okay, let's do another one. So we'll erase this bit again. So keeping our acronyms at the top there, we'll do one more example here where we have our right angled triangle. Okay, and our angle of interest is going to be this one down here. This is going to be 20 degrees now. Again, this isn't to scale. Okay, we'll let this side length here be 5, and this side length here is z. That's what it is that we're trying to find. So if we label our sides, well, we've got our angle theta in here. This side would have to be our adjacent, this side our hypotenuse, and this side as our opposite. The sides of interest to me are my opposite and my adjacent. So if we look at our acronym, the one that incorporates that is going to be my tangent. So I can write that equation down. The tan of theta is equal to the opposite divided by the adjacent. Okay, now I know that my theta is equal to 20 degrees. So we take the tan of 20 degrees. My opposite, that's what I'm trying to find. That's my z. And my adjacent, that's my 5 down the bottom there. Okay. Now, again, if I want to rearrange this equation for z, that's what I'm trying to find, I can multiply both sides by 5. So that's going to get rid of my divide by 5, so they're going to cancel out. I just get my z. And over on this side, I've got my 5 times the tan of 20 degrees. And if you put this bit here into a calculator, we get that z here is equal to about 1.8. So again, using our trigonometry there to solve for a side of a right angled triangle based off of one side and one angle, which is a little bit different to Pythagoras. The next part that I want to look at now, and we're going to do 3 examples. The only bit that's really going to change here is potentially how we have to solve our equation, okay? And it might just get a little bit trickier. So if we do another example, we can have our right angle triangle look something like this, and we've got this little right angle in here. And this angle here can be 45 degrees. And we will let this side be x and this side be 7. Okay, so if we label our sides and our angles, so that's our angle of interest, that's our theta. This would have to be our hypotenuse. This side here would have to be our opposite, which would leave this side here as our adjacent. So the sides of interest to us here are our hypotenuse and our opposite. Okay, so the acronym that we're going to use is our sine. So let's write that formula out. We've got the sine of theta is equal to the opposite divided by the hypotenuse. And let's now put some numbers in. So theta we know is 45 degrees. Our opposite side we know is 7. And our hypotenuse, that's what we're trying to find. That's our x there. Okay, now to rearrange this equation, this can be a little bit tricky, okay, and there is a little shortcut that we can do, okay, and it's okay to remember the shortcut, but I'm also going to go through why it works. The shortcut is that we can just swap the sine of 45 bit and the x around. So if we did that, we just swap those around, we get x equals 7 divided by sine of 45 degrees. Now that's the little shortcut method, but I will go through why this works. So if I was to multiply both sides by x here, so I'll multiply that side by x and I'll multiply this side here by x, what do I get? Well, this x and this x here cancel, so I'm left with 7. And over on my left-hand side, I'll get x times the sine of 45 degrees. Now to solve this equation, what's with my x that I don't like? Well, it's that sine of 45 degrees. So I can divide now by sine of 45 degrees. Okay, divide this side by the sine of 45 degrees. And I'm now just left with, I see that they cancel, I'm left with my x is equal to 7 divided by the sine of 45 degrees, which is exactly what I see up here. Okay, so it does work. The shortcut or the little shortcut method does work, but that's algebraically why. But from this point forward, you probably could just use the shortcut method. That would be fine. So if you put this into a calculator, you should get that x is about 9.9. Okay, so you just pop that into the calculator, you get about 9.9. So that tells us that this side length here is about 9.9 in length. Let's do another one. So we'll erase this again. So we can have a right angle triangle now, which looks something like this. And we've got our right angle up here at the top. And this can be 35 degrees, again, not to scale. And this side can be 13 and this side can be y. So remembering again that this angle in here would be our theta, okay? This would be our hypotenuse. This one here looks like our adjacent, and this one over here is our opposite. So the two that are of interest to me is my A and my H, so we're going to use cosine now. So I've got my formula, the cosine of theta is equal to the adjacent divided by the hypotenuse. And now I can put some numbers in. So my theta, my angle that I've got here is 35 degrees. My adjacent side is my 13, and my hypotenuse is the one that I'm looking for. That's my y. So again, we can just use our shortcut method here and we just swap these around, okay? But I have shown you algebraically why that's possible. We get y equals 13 over the cosine of 35 degrees, and if you were to put that into a calculator, you should get about 15.9. Okay, so we've worked out that y here would be 15.9 long. One more example where hopefully we'll get to use the tangent. So we can have a right angle triangle here maybe that looks like this, okay? And we can have our angle in here of 70 degrees. We'll let this side length up here be 6, and this one here be z. That's what we're trying to find. Okay, now I know that this angle in here is my theta angle. This side here looks like my adjacent, and this side over here is my opposite. So immediately we see that the two sides of interest are my opposite and my adjacent, which gives me my tangent formula. So I take the tan of my angle, which is 70 degrees, and that is to be equal to my opposite, which is my 6, divided by my adjacent, which is my z. Okay, now I can use my shortcut method here where I just swap these little guys around, and that helps me find what z is. So I get z is equal to 6 divided by the tangent of 70 degrees. And if you were to put that bit into a calculator, we should see that z here is equal to about 2.2. So we've worked out that this side length here is 2.2 in length. So that's it for trigonometry in terms of finding side lengths. In a later video, we're going to get given two sides and have to try and find out what the angle is.